Hi everyone, welcome back to my channel Math Shala. In this video, we'll be continuing with part 2 of exercise 9.6 of Arithmetic Progression chapter. In the previous part of this exercise, we looked into the first main question which had multiple sub questions. In this video, we'll continue with the next questions of this exercise. The first question of this part of exercise is going to be question number 2. Find the sum up to n terms of the arithmetic progression 5, 2, minus 1, minus 4, minus 7 and so on. Here an AP is given to us and we need to find sum up to n terms. Let us note down the given data first. A or A1, that is first term, is given to me as 5 and we need to keep n as it is because we need to find sum up to n terms. And the common difference D is given to me as 2 minus 5, that is second term minus first term. 2 minus 5 will give me minus 3 here. Applying the formula Sn equal to n by 2 into 2a plus n minus 1 into D here. Wherever n is there, I'll keep this n as it is. Wherever a is there, I'll substitute 5, that is the first term. And D we just calculated, that is minus 3 here. Substituting all the values, Sn equal to n by 2, 2 into 5 plus n minus 1 into minus 3 here. Further simplifying, n by 2 I'll keep as it is. 5 into 2 is 10 minus this minus we got because when I multiply this minus 3 to this whole term, that is whatever terms present inside this bracket, it will be plus n into minus 3, that will be minus 3n, minus of minus, that is plus 3 1 3. Therefore Sn equal to n by 2, 10 plus 3 is 13 minus 3n here. And this is the sum up to n terms of this arithmetic progression. Next question, question number 3, which says find the sum of n terms of an AP whose nth term is given by an equal to 5 minus 6n. Here instead of giving an arithmetic progression, he has given us nth term of that AP, and using this nth term we need to find sum of n terms of this AP. Let us see how we can do that. There are two methods to solve this problem. Let us look into all the methods one by one. First method, in which I will calculate using an, that is nth term. I'll first calculate first term, then I'll calculate second term. Using those two terms, I can calculate common difference D. Then we'll further proceed. So first term I'll calculate, that is A or A1, as 5 minus 6 into 1. This you already know how to calculate any term if you know the nth term of that AP. Wherever n is there, I'll substitute 1 here. In order to calculate first term. 5 minus 6 into 1 will give me minus 1, which is my first term, and in place of n I'll just keep it as n. Then coming to the second term, that is A2 is equal to 5 minus 6 into 2. In place of n I'll put 2 in order to calculate second term. This will give me minus 7. Now using these two terms, I'll calculate common difference, that is second term minus first term. Second term is minus 7 minus first term is minus 1 here. Minus 7 minus of minus 1 is plus 1. Minus 7 plus 1 will give me minus 6. Therefore, common difference of this AP is minus 6. Now, using all these available data, I can calculate sum up to n terms, that is Sn equal to n by 2, 2a plus n minus 1 into D. Substituting all the known values. Sn equal to n by 2. In place of a, I will substitute minus 1, and in place of D, I will substitute minus 6. Therefore, Sn equal to n by 2. 2 into minus 1 is minus 2. When I multiply this minus 6 inside this bracket of n minus 1, I'll get minus 6n. 6 into 1 is 6, that is plus 6. Further simplifying, n by 2, plus 6 minus 2 is plus 4, minus 6n I'll keep as it is. Further, I can take 2 common from these two terms. You can see here, when I take these 2 common here, that will be n by 2 as it is into 2 into 2 minus 3n here. Now further I can cancel out this 2 with numerator and denominator. Then lastly I'll get the answer as Sn equal to, when I multiply this remaining n inside this bracket, I'll get n into 2 is 2n minus n into 3n is 3n square. Therefore sum of n terms of this AP is given as 2n minus 3n square. I told we can solve this method, this problem by two methods. Let us look into the other method. Here I need not calculate second term and the common difference. I can directly solve this problem without calculating these two terms. Further, two steps are reduced for us. Using an equal to 5 minus 6n, I'll just calculate the first term, that is a or a1 is equal to 5 minus 6 into 1, which will give me minus 1, and n is as it is, that is n. Instead of calculating A2 and D, I'll solve it by sum with modification. Let us see what we can do that. Applying same formula again, Sn equal to n by 2 into 2a plus n minus 1 into d. What I'll do here is n by 2 I'll keep as it is. Just one modification, that is 2a, I can write it as a plus a. A plus a will give me 2a. I'm just splitting this as a plus a, and further I'll writing plus n minus 1 into d as it is. Now you can see here this term a plus n minus 1 into d. This is nothing but an formula, means if I have an, that is the nth term of an AP, that can be expanded as a plus n minus 1 into d. So already I know nth term, that is an is given to me. So instead of a plus n minus 1 into d, I'll just substitute nth term, because a plus n minus 1 into d is again nth term and nth term is given to me. I'll just substitute 5 minus 6n in this place. Therefore, this formula will reduce to n by 2. A will remain, this first a will remain as it is. Therefore, substituting a value, that is minus 1, which we just calculated, instead of a plus n minus 1 into d, I will just put 5 minus 6n directly. Now, further simplifying this, Sn equal to n by 2, 5 minus 1 is 4, minus 6n I'll keep as it is. Now I can take 2 common from this, n by 2 into 2 minus 3n, and this 2 get cancelled out, and therefore again I'll get the same answer as previous one, that is Sn equal to 2n minus 3n square here. Hope you understood what modification we made here, and that is how we have reduced 2 steps, that is calculating A2 and D. Next question is question number 4, which says find the sum of last 10 terms of the AP 8, 10, 12, 14, 16 and so on up to 126. He has asked us to calculate sum of last 10 terms, which we do not know what are those 10 terms. Without knowing those terms also we can find sum. Let us see how we can do that. Very simple. We are going to first note down all the given data. For me here a is given, that is 8, that is first term, and we need to find sum up to n terms, that is from last 10 terms. Let us calculate the common difference d is equal to second term minus first term, that is 10 minus 8 is going to give me answer as 2. Now what we need to do, if we want to find sum of last 10 terms, we need to write this AP in a reverse manner, that is beginning from 126. Let us see how we can do that. In order to create an AP from end, what we can do is, suppose there is an example in this AP, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the 10 terms present in this AP. Now you can see here the common difference of this AP is 1. That is, if I add 1 to first term, I will get second term. When I add 1 to second term, I will get third term, and so on. Now, if I want to write this AP in reverse manner, what I will have to do? I will consider first term as the last term of my previous AP. So, first term will be 10. Next term will be 9. You can see here I am just writing it from left to right. So you can see 10, 9, 8, 7, 6 and so on, it will continue. If you observe here, common difference will be minus 1. First term 10, if I subtract 1 from that, I'll get 9. 1 subtraction, again I'll get 8. What one observation you can make here is, if I just change the sign of common difference, I can write an AP in the reverse manner. So here my A is going to be last term of the original AP, and common difference will be, number will be same, I mean value will be same, but only the sign we need to reverse. So in our case, this is the AP. If I want to modify this AP by writing it from end, my first term will be 126 and common difference will be same 2 but with negative sign, that is common difference will be minus 2. Let us see how we can write that considering A or A1. So as I told, it is 126 will be my first term and common difference will be minus 2. So it was plus 2 in the original case, and in the modified case it will be minus 2. Now from the end I'll write 10 terms which I need to calculate the sum of 10 terms. Therefore AP new or modified AP is going to be 126, 124 and so on, and for this modified AP last term will be first term of our original AP, that is nothing but 8. Now I have formed new AP. Now using this AP I can directly calculate sum of 10 terms. Remember, for this new modified AP, sum of 10 terms will be from beginning because we have written this entire AP in the reverse manner. Therefore Sn equal to n by 2 into 2a plus n minus 1 into d. S10 will be 10 by 2. I'll substitute wherever n is there, I'll put 10, and wherever a is there, I'll put first term, that is 126 in case of new AP, and common difference will be minus 2 in case of new AP. Substituting all these values and further simplifying, I'll get 10 by 2 is 2, 10 by 2 is 5, 126 into 2 is 252, and 10 minus 1 is 9, 9 into minus 2 will be minus 18. Therefore, when I simplify this, I'll get answer as sum of 10 terms of this AP, sum of last 10 terms of this AP is going to give me 1170. Next question, question number 5. Find the sum of first 15 terms of each of the following sequences having nth term as. Further sub questions are present in this question. That is, the first sub question in this is an is given as 3 plus 4n, and we need to find sum up to 15 terms. Let us see how we can do that. In order to calculate sum of 15 terms, I need first term, that is a, and common difference d, and I need n value. N value is given to me, that is 15. Let us see how we can do that. Again, we can solve this by two methods. Let us see one by one. Here a or a1, that is first term, is I need to calculate. Therefore, wherever n is there, if I substitute 1 in this an formula, I'll get first term. Therefore, first term is 3 plus 4 into 1 will give me 7, and n is equal to 15 here. I'll consider second term. In order to calculate the common difference d, I will also require second term. Therefore, I'll calculate second term also using this an formula. Wherever n is there, I'll substitute 2. Therefore, second term will be 3 plus 4 into 2. That will give me 11 here. And the common difference d will be calculated as a2 minus a1, that is second term minus first term. Second term is 11 minus first term is 7. 11 minus 7 will give me 4. Applying the regular formula, that is Sn equal to n by 2 into 2a plus n minus 1 into d. Substituting all the available value, I'll get S15 equal to 15 by 2 into 2 into 7 plus 15 minus 1 into d is 4 here. You can see S15 as 15 by 2, 7 into 2 is 14 plus 15 minus 1 is 14 into 4. S15 is equal to 15 by 2, 14 into 4 will give me 56, 56 plus 14 is 70. S15 is 15 by 2 into 70. Therefore, S15 equal to 70 I can cancel by 2, that will give me 35. 35 into 15. Therefore, S15 will give me answer as 525. Therefore, sum of 15 terms of this AP whose nth term is given as 3 plus 4n is nothing but 525. I told one more method we can solve. There is just little modification in the formula that we'll see. Again, I'll note on the given data a or a1, that is 3 plus 4 into 1 equal to 7, and n is 15. Here I did not calculate d and a2 again. I'll just modify the main formula, this formula, in next manner. That is 15th term I'll calculate directly. Okay, last 15th term is a15 is equal to 3 plus 4 into 15, that is 63 I'll be getting. Using this first term and nth term, I'll directly calculate the sum up to 15th term. Means I need to calculate sum up to 15th term, therefore I calculated directly the last term, that is 15th term. If I had to suppose calculate sum up to 25 term, I would have directly calculated sum of 25th, directly calculated 25th term. Then I would have used one more formula, that is Sn equal to n by 2 into a plus l. That is L is nothing but last term whichever I want to calculate here. Using this one new formula, I can calculate sum up to 15th term. Wherever n is there, I'll put 15. Wherever a is there, I'll put first term, and wherever L is there, I'll put last term up to which I need to calculate the sum. Substituting all the values, I'll be getting 15 by 2, 63 plus 7 is 70. Again 70 by 2 is nothing but 35. 15 into 35 will give me 525. Here we need not calculate common difference d, and just one more extra term that we need to calculate is 15th term. Coming to the next sub question of question number 5. Here instead of an, just modification, bn is given, only change in letter, nothing much. Bn is equal to 5 plus 2n. Using the formula, I'll calculate first term b or b1. equal to 5 into 2, 5 plus 2 into, in place of n I'll substitute 1 because I want first term. Therefore I'll get first term as 7 and I need to calculate sum up to 15 terms, therefore n will be 15. Applying the formula, in order to calculate 15 term I need 15th term, like sum up to 15 terms I need 15th term. Therefore B15 is equal to 5 plus 2 into 15, that is nothing but 35. Applying this same formula again, Sn equal to n by 2 into a plus l, where l is last term up to which we need to calculate the sum. Substituting all the values, yes, in place of n I'll put 15 here. 15 by 2 into first term is 7 again plus last term is 35. Adding these two I will get 42. Cancelling out this 42 by 2 I will get 21. Therefore sum of 15 terms is 15 into 21, that will give me 350. Next sub question is xn. Instead of a, now he has given xn, that is equal to 6 minus n. In the similar manner as we solved this second problem, we'll calculate again. First term ax or x1 will be equal to 6 minus 1, that is 5, and sum up to n terms, that is n equal to 15. Therefore last term again I will calculate. 15th term is 6 minus 15, that will give me minus 9. Applying the same formula, Sn equal to n by 2 into a plus l, I'll get 15 by 2 into 5 plus l is minus 9 here. So minus 9 I'll put in bracket. Therefore it will be 5 minus 9, that will give me minus 4. Therefore cancelling out this minus 4 with 2, I'll get minus 2. 15 into minus 2 will be minus 30. Therefore sum of 15 terms of this AP is going to give me answer as minus 30. Coming to the last sub question of this question number 5, that is yn equal to 9 minus 5n. Here instead of again a, he has given mentioned as y. No problem, again we'll solve in the similar manner. First I'll calculate the first term, that is y or y1 is equal to 9 minus 5 into 1, that will give me 4 and n is 15. And the last term, that is 15th term, will be 9 minus 5 into 15, that will give me minus 66 here. Further applying same formula, Sn equal to n by 2 into a plus l. I'll substitute all the known values here. In place of n I'll put 15, in place of a I'll put 4, and in place of l I'll put 66. Because of this minus sign we have minus here. Now 4 minus 66 will give me minus 62. Cancelling out this minus 62 by 2, I'll get minus 31. Therefore sum of 15 terms will be 15 into minus 31, that will give me minus 465. With this problem we are going to end part 2 of exercise 9.6. In my next video I will come up with part 3 of exercise 9.6, wherein we'll be looking into further problems of exercise 9.6. Till then, have a good day. Thanks for watching the video. Like, share and subscribe so that all the class 10 and SSLC students can reach out to this special content for their better preparation. Thank you for watching the video once again.